for how the free surface, in fact, free surface here I shown like this. So basically the free surface will be of like this. It will wet completely. Or if the angle of contact is given, okay, you can take the angle of contact. No, okay, this is the of immerse, no? So what is this everything? This is what the free surface of a water. I'm showing like this. Tell me what are the things that are, what are the forces that will be acting? Now you know enough ideas. A buoyant force will act. So what is the question? A wooden sphere is of wooden sphere with half of the volume in water. Okay, there's a condition given. Tell me what are the force acting? Buoyant force, weight of the solid. Tell me how the force due to surface tension. How the force due to surface tension. I'll show by this color arrow. Tangentially, no. So how the liquid will exert force on this one? So it will act tangentially. So the force due to surface tension will act at one point or at several points, everywhere surrounding. Okay, I'll try to show the video. So everywhere, I don't have spherical object. Okay, if it is like this, the force will be everywhere like this, tangential. All of a sudden, I don't have ball, no. Football, my kids' ball somewhere they have kept it. Okay, tomorrow we'll see that. Yeah, look at now this one. So I think at least a ring is needed. This is some lid. Okay, you can see there's this particular thing. This particular thing is different. How the force will be acting everywhere like this. Are you able to see this? Black color pen visible?
Yes, sir.
The black color one. Somebody please don't talk. The video will not come. Okay, are you seeing that pen will not act if angle of contact. So now what is it? This pen? Yeah. So look at this pen. So what it will show? It will show the direction of the force, no? Because the free surface will be like this, direction of force. Then this is a solid, and this is a like a the pen is what will show the direction of force. I think there's a it is on this side. Yeah. Tell me what is the angle of contact? This will be the angle of contact. Are you seeing the gap between that? This will be the angle of contact, no? Then now the force will not act vertically, will act like this. Everywhere like this. Even on this side. The force will be acting here. Everywhere will not act vertically, everywhere will acting some angle, that one. So based on that, okay, this should be the angle of contact, theta. What is theta? Theta, let it be angle of contact. Density of food and density of liquid. Let it be water, that one. Shall we equate forces now at equilibrium? At equilibrium, tell me what are the forces you can. Buoyant force will be balanced by weight of the solid plus force due to surface tension. And what is the buoyant force? Density of liquid, volume immersed, 2 by 3 pi r cube g. Weight of the solid, sigma s, 4 by 3 pi r cube g. What to write force due to surface tension? Will act at only these 2 points? No, it will act everywhere here, no? See, this is what student has to learn. That's all. See, force due to surface tension is not a point force. Are you getting no? It will act everywhere on the free surface. So I'm giving plain diagram. So what you should assume, everywhere like this, the free surface will be there. I think some gulab jamun in that particular liquid when it's floating, half of the gulab jamun will be there, no? So how the that sugar like a liquid will be, it will be of this particular shape. Plain diagram will be like this. So then the force will be acting everywhere tangential to free surface. So therefore, what should be the force due to surface tension? 2 pi r into surface tension into cos theta. And now this is what you have to digest. If you can learn this, it's very, say, this student really should bring some imagination. What is 2 pi r? Circumference length. Everywhere the force will be due to surface tension will be acting no, here like this. So if you go around like this, will come. So why you are writing like this? What is the definition for surface tension? What is this L now? What do you mean by L? L stands. L is what? The imaginary line what you're drawn. No? So at the free surface, so what is the free surface? There's everywhere free surface. So you have to go around like this 2 pi r. Why not two like a sir? You are writing. Why not two? The force is not acting only at these 2 points. Will act everywhere here. The liquid is in contact with everywhere on the wood when you go around a circle. That's why this theta will come into picture. So students are thinking that they want to resolve only these two forces. That is a very poor imagination. Plain diagram means you don't know anything about, you have never seen any spherical object floating in a liquid and how the water will be. Tell me, like, for this you should take ITJ foundation course. Nothing, no. The physical world you should have noticed very clearly. So put some plastic ball in the water and make observation. Make observation. It's very, very important. All this, see, water is available in everywhere. Bucket, you fill up different type of objects, let it float and see how the water surface will be. Finish show. Then numericals you can manage. Okay, there's the equation what you can put. What is theta? Theta is angle of contact. I made it. And now if a water wets wood completely, tell me what happened to theta? Theta in that case will become 0. Theta will be say like a 1 degree, 5 degree, that one. What are that angle? They give, okay, substitute here. If it puts like water wets completely, then you have to show this Fs downward. This forces will be downward. Able to understand? Horizontal force should be 0, no? If you resolve this. Only vertical, the net force acting by the surface tension on the wood will be downward. Got the idea, no? So these are the numericals. Are there any student can solve this provided what pen? You should have better 3D geometry. Okay, now let's take the another thing instead of this. We'll make iron spear to float in a, I'll erase this, this will confuse the same diagram. There's a iron. So how the mercury free surface will be of like this. clear this. So now it is floating. So weight of the solid will act here. How the force due to surface tension will act in this direction. And we know what is that. If you want, you write Fs dash, because I think some students are sir, why you're not writing. Total force will be, you should take component of all these forces at everywhere. Surface tension into perimeter into component of that. This will be, so here iron sphere of immersed in mercury. What is the angle of contact? I think this is what angle of contact will define. No, I'll call alpha because theta every time we are using. So how you define angle of contact? The angle measured between the angle measured between the tangent on inside the liquid and the solid. This is a solid. This is a liquid. I'll draw a tangent. I'll draw a tangent in the liquid. This is what the angle of contact here. Okay, let's write equation now. Some small, because we are measuring like this alpha. Yeah. Now for equilibrium, the force due to surface tension plus buoyancy should balance weight of force due to surface tension 2 pi r st into cos theta. What is st? Surface tension plus buoyant force. Density of mercury rho L 2 by 3 pi r cube g. This will be density of iron rho s. Let me take it. See, we know weight, we know buoyancy. Surface tension is something new, you're learning it. So what is the method here? The horizontal force will be 0. So whenever a solid floating in a liquid, so what you should check, whether the liquid wets the solid or not. Based on that, the angle of, if it will not wet, then alpha should be obtuse. If it wets, then alpha should be acute. Getting the idea? Try to see that. So every numerical weapon, the solid which comes in contact with the liquid, where the solid comes in contact with the liquid, check for the condition, whether it will wet or not, or what is the angle of contact given. Based on that, draw the free surface. Then the force due to surface tension should act tangential to surface. Now you have to ask question, what is the force exerted by the wooden sphere on the free surface? Anybody wants to reply? Shall I show upward, opposite to this Fs dash? Because Newton's third law, action, reaction, equivalent, opposite. What is this F dash? Force exerted by the free surface on the wooden sphere. By the wooden sphere on free surface should be opposite. Getting the idea? No? So it will be like this. I'm not bothered. I'm bothered about on the wood. No. So these are the forces acting on what? On the wood. So on the iron sphere. This is what? On the wood. I think we should minutely analyze the situation. Nothing is there. I'm not bothered on free surface. I'm not bothered on free surface. I'm more interested on the iron sphere. And what is alpha? Sorry, this alpha. Alpha is angle of contact. Theta is angle of contact. So like this, what happens? The conditions will come. Instead of this wooden sphere or wooden something, any other shaped object will come. Okay, you know how to make out that one. So carry on that. Anybody have doubts? Please clarify, because this is something more on the geometry based. No, if you have doubts, you can clarify it. We have some 5 minutes time. Any doubts, you can clarify. Why we didn't consider? Because there what will happen, see, we have to learn in order, no? First, fluid statics we should know properly. Without fluid statics, then how you learn surface tension? First, we should know the fluid statics dynamics.
Sir,
Yeah.
sir, but there also we have to consider this force, no, sir.
We should consider, pa, we are learning. See, we are not gathering information. You should learn in order. Everywhere will be there. After learning this chapter, then okay, you work out all. In a question, if they say surface tension and the density of liquid, no, then you should consider even surface tension. If they don't give surface tension, then it's only pure fluid static problem. Getting the idea?
Okay, sir.
Anybody having doubt, please clarify, because numericals will be just, I think there's no any concept. A student must have the general, how the diagram will appear and how the force will be acting. You can practice questions on this in Icon and or Cengage book. Almost a basic. Don't go for capillary rise, capillary fall, all that one. Only force due to surface tension numericals are there, you practice few. Any doubt, anybody? If you have doubt, you can clarify. Yeah, don't add colors in your notebook, because already this available, no? Because just I wanted to give exact thing, that's why I'm just coloring it. It will be waste of time for you to do coloring for your notebook. Just plain diagram, black and white, that'll be sufficient. Student can imagine easily with this color. That's why I'm just taking help of these colors here. So this is the free surface. So always what you should do in surface tension, what is the priority you should give? Inside the liquid will you go, or the free surface of liquid will you give priority? The free surface of a liquid. Why we don't see surface tension on the, why we don't see surface tension inside the liquid? Why we see only on the surface? Because the name itself is tell, no, the molecules which are there on the surface, what happen, they are under tension, they are under trouble. So what happened, the molecules which are there below, what happen, they're trying to pull it down. Somehow what happen, the molecules which are there on the top, they will manage themselves, so they are under stress. They're not that easily, they're not happy, they're struggling a lot to retain their position. They're struggling, what happen, they are trying to support one other. One molecule will try to support the other molecule, adjacent molecule. So they'll exert extra force to retain their position. That extra force per unit length will be the surface tension. And how do that force will act? Tangential to free surface. And it's a conservative and it's a cohesive force. This idea. Getting now method. Any doubt you can clarify, because this is the, you can say that the core part of surface tension. That's why I took almost more time, almost one class. If you just open the book, no, angle of contact, one definition is there, two diagrams are there, it's over. So almost 2 hours I spent only to generate that idea, force due to surface tension, how do you interact? Because numericals are based only on that. The entire our numerical discussion is based on that one. Please, all of you do think, and try to work out numericals. At least you'll get an idea. So maximum diagrams, drawing diagrams, that skill is what you should acquire now. And this is a very challenging chapter. I'm telling this one, really. A student, what mean, how you'll imagine that diagram, because everything 3D diagram will be there. You should be able to imagine that 2D, convert that into 2D diagram, draw it, show the forces, and work out the numericals. Shall I stop the class? I think we can get ready for the next one.